Now we're on this side of the street with ion exchange, which is the second treatment system to remove perchlorate, which is the rocket fuel additive. Air stripping does not remove perchlorate because it is a salt, not a volatile organic.
What's he talking about? Everybody knows what salt is.
You're thinking of table salt.
The word salt has two meanings.
Most of the time we mean table salt, which is what we use to season our food. Scientifically speaking, salts are a type of chemical. They're neutral compounds made of a metal, which forms a positive ion, and a non-metal, which forms a negative anion. And it all dissolves in water easily.
Salts dissolved in water are called electrolytes because once they are dissolved in water, they are positively charged ions and negatively charged anions.
And there are many kinds of salts.
Table salt is sodium chloride. Sodium is a metal and chlorine is a non-metal. Our bodies need sodium chloride in our diet.
Potassium chloride, used as a table salt substitute.
Magnesium sulfate, like Epsom salts, used medicinally.
Sodium bicarbonate, which you know as baking soda, used in baking cookies, cakes, muffins, and even pancakes.
Oh, and look at these very pretty blue crystals of copper sulfate used to control bacteria and fungi in vegetables, fruits, and other crops. All salts dissolve in water. Want to see?
Yeah, show me.
Pour some table salt, that is sodium chloride, into the test tube.
And you take this test tube, and we'll put some copper sulfate into that. Perfect. Now you pour some water, about half full. That's good. And some water here, and then put the stopper on. That's good. Put the stopper on. Now shake them up. There we go. See, look. The salt crystals have disappeared.
The solution is clear like pure water with the table salt.
And clear blue for copper sulfate. The salts are invisible, but they're still there.
Oh yeah? Prove it.
Oh, okay. So look, all you need to do is pour a little of that solution there and a little of yours there, and let's see what happens. Okay, so we'll pour each of these solutions in a plate and let it evaporate. And voila, hours later, the salt crystals have reappeared.
We call that residue an evaporate.
See how that works?
If you add the water again, the salt crystals will disappear again.
So it's a cycle.
It works that way in nature too.
So, here is some salt evaporate on the dirt. Add some rain and it disappears, dissolved.
If there is any kind of salt on the ground, it will dissolve into the rainwater and travel wherever it goes in the environment.
The dissolved salts percolate down through the layers of soil, seeping into the ground and towards the groundwater.
Eventually, after many rainfalls, it reaches the groundwater. As it redissolves, it forms a plume that gradually moves through the groundwater. Some salts are beneficial, but some salts are extremely poisonous.
Like the salts Dan was talking about, right? Perchlorate.
Exactly. Sodium perchlorate and ammonium perchlorate are used in rocket fuel.
Rocket fuel got into our water supply?
Yes, that's the problem.
You see, years ago, in the 40s, 50s, and 60s, rocket fuel was dumped into the ground by the aerospace industry, expected to evaporate harmlessly. But as you can see, once it evaporates, it leaves the perchlorate salt to redissolve and percolate down through the soil.
And we can't see it, taste it, or smell it?
That's right. Just like this test tube containing sodium chloride solution, it's colorless, plus there's not enough to taste.
How do we know that it's in our water?
Well, water agencies are constantly monitoring for water quality. In the 1990s, perchlorate was detected in California's groundwater.
What does perchlorate do?
One thing it does is ignite. It is in rocket fuel and it is in matches.
Whoa!
You wouldn't want that in your drinking water.
If you were to ingest it, It would interfere with your thyroid gland that regulates growth and metabolism. It interferes with the uptake of iodine that makes your thyroid work. It's because the perchlorate ion and the iodine ion are exactly the same diameter.
How do we get it out of the water?
Let's see what Dan has to say about that.
Tiny little resin beads, little plastic resin beads, are in these vessels back here. There are 6 pair of vessels in a lead-lag configuration. The vessels have the resin beads inside them, and the water goes from one of the vessels, the lead vessel, goes through the configuration of piping that you see over here between the 2 vessels. It goes into the lag vessel and is done a second treatment type. You did the first one with the lead, you're doing this again with the lag to assure that all of the perchlorate has been removed, and then the water goes off, goes through this filter behind me, and then goes off back across the street to another treatment system that we'll get into in a bit.
Let me be your salty dog, clean up the water all day long. Won't you let me be your salty dog? Hey there, water prospector here.
Hi there, you salty dog.
Say, I'm here to show you how to do the one-pass ion exchange. Are you ready?
Yes.
Grab your partner, good to go. First we got the water in the gray and the perchlorate ion in the red. Then we've got the tank full of resin beads in the black and polka dot with the water ion in the blue. 1, 2, 3, 4. Percolate the water through the tank full of beads. Grab that ion right out of the stream. Do the one pass. Do-si-do. Ion for ion. Exchange. Now the water's clean and good to go. And the percolated perchlorate's trapped in the bead, out of the water and out of the flow.
Why, you old salty dog, you done good.
You too, darn tootin'. As I always say, who needs gold? There's water in them thar hills. Clean water!